Welcome to MRL. In this learning session, we will continue to learn the application of the different formulas used in coordinate geometry. In the previous learning session, we learnt about the application of distance formula. We'll continue from there. Now, another important application of distance formula is to find if the 3 points A, x1, y1, B, x2, y2 and C, x3, y3 are collinear. That means the 3 points A, B and C lie on the same line. Now, we are given A, x1, y1, B, x2, y2, C, x3, y3 lying on a line ABC. But are they lying, if they lie on ABC, or are they collinear or not, we have to find out, and that is done using a distance formula. And for that, find the distance AB, BC and AC and check if AC is equal to AB plus BC, then the points ABC are collinear. So that is how we can use distance formula to prove that the 3 points given are collinear. Now the next important application of distance formula is to find the coordinates of a point equidistant from 2 points A, x1, y1 and B, x2, y2. We are given a point A, x1, y1, we are given a point B, x2, y2, there is another point C, xy. Now we are given that AC, the distance AC and the distance BC are equal. We have to find the coordinates of the point C. Now AC is equal to BC, which is given to us, then AC square is equal to BC square. Find AC and BC by distance formula and then equate them and solve and simplify to get the coordinates of the point C. Now the next is the application of section formula. Now the section formula, as we know, is Cxy is equal to mx2 plus nx1 divided by m plus n, my2 plus ny1 divided by m plus n. And this formula can be used to find out the coordinates of the point which divides a line segment in the ratio m is to n. That means A, x1, y1, B, x2, y2 are 2 points in a coordinate plane, and Cxy is another point which divides the join of the points A and B, that is the distance AB, into in the ratio m is to n. It divides Cxy divides AB in the ratio m is to n. Now to find out the coordinates of Cxy, we can use the section formula. Very simple. We can just substitute the values of x1, x2, y1, y2, the values m and n, and simplify to get x and y. Remember that. Now the next important application is how to find the area of a triangle. Now the area of a triangle whose vertices are given can be found out in two different methods. The first method is we can use the distance formula to find out the distances AB, BC and AC, and after knowing the distance AB, BC and AC, supposing AB is A, BC is B and AC is C, we know the three distances, then use the Heron's formula, that is triangle is equal to SS minus AS minus BS minus C, so where S is equal to A plus B plus C divided by 2. So knowing A, B and C and knowing the semi-perimeter of the triangle, we can use the Heron's formula to find out the area of a triangle. So therefore in this method, the area of triangle can be found out by two different formulas. One is the distance formula and the second one is the Heron's formula. So that is the first method. In the second method, we can use the area of triangle formula. So now we are given a triangle ABC, A, x1, y1, B, x2, y2 and C, x3, y3 are the coordinates of the triangle ABC. We can use the area of triangle formula, that is the area of triangle ABC is equal to half in the bracket x1, y2 minus y3 plus x2, y3 minus y2 and x3, y1 minus y2. We can use this formula, substitute the values of x1, y1, y2, x1, x2, x3 and y1, y2, y3 in this formula to get the area of the triangle ABC whose coordinates are given, whose the vertices of the coordinates are given. Now here please understand that there is a possibility of getting a negative sign with area, but remember the magnitude of area is to be taken. The negative sign only indicates that whether the vertices are taken clockwise or anti-clockwise. Therefore take only the magnitude. If the negative sign comes, neglect the negative sign. Remember that. Now the next important application of the area of triangle formula is to find the area of a quadrilateral. One application is we can find the area of a triangle. Now the next important application is to find the area of a quadrilateral. Here we have given a quadrilateral ABCD and the vertices of ABCD are given, that is x1, y1, A, x1, y1, B, x2, y2, C, x3, y3 and D, x4, y4 are the vertices of the quadrilateral. Now join AC. Join AC, the diagonal is AC here. Now to find the area of the quadrilateral, find the area of the triangle 1 here, this triangle, that is ABC. Find the area of the triangle 2, that is ACD, then add them to get the area of the quadrilateral ABCD. Rather here we have to apply the area of triangle formula two times, one for triangle 1, another for triangle 2, and then add to get the area of the quadrilateral. Remember that. And also the area of triangle formula can be used to show that the points are collinear. We had used distance formula to prove that the points are collinear. We can also use the area of quadrilateral formula to prove that the points are collinear. And for that, what we can do is find the coordinates are given here. Ax1, y1, bx2, y2, cx3, y3 are the coordinates of the points a, b and c. Find the area of using these coordinates. Find the area of the area. Use the area of triangle formula. Using these coordinates, find the area. If the area becomes 0, if the area of the triangle is 0, then the 3 points a, b, c and a, b and c are collinear. So the method is very simple. Use the area of triangle formula. Find the area. If area is equal to 0, if area of triangle is 0, then the points a, b and c are collinear. So these are again important applications of the area of triangle formula. So please remember these applications. Use them for finding out or proving the important examples given to us. Okay, thank you.